What if I told you that right now, as you watch this video, a spacecraft 8.7 billion kilometers from Earth is hunting for something that makes up 27% of our universe but has never been directly detected? New Horizons, the probe that gave us our first close-up of Pluto, has been secretly reprogrammed for a mission so ambitious that NASA kept it classified until 2026. It's now searching for dark matter in a region where the laws of physics operate differently than anywhere else we can reach. And in the last 3 months alone, it's detected 17 anomalies that could finally solve the greatest mystery in modern physics. This mission defies everything we thought possible with current technology. Dark matter has eluded the world's most sophisticated detectors for decades: massive underground laboratories shielded from cosmic radiation, particle accelerators smashing atoms at near light speed, and space telescopes scanning billions of galaxies. Yet somehow, a piano-sized probe launched in 2006 with technology from the early 2000s might be the first to detect it directly. The reason is location. New Horizons is now operating in what scientists call the pristine zone, a region beyond all the noise and interference of the inner solar system where dark matter might behave differently. The spacecraft is detecting particle interactions 300 times more sensitive than any detector on Earth. It's measuring magnetic field fluctuations at the quantum level in a region where the solar wind no longer drowns out the subtle signals. Most astonishing of all, New Horizons has detected what appears to be a dark matter wake, a pattern of disturbances that follows our solar system's movement through the galaxy, like ripples behind a boat. Dr. Elena Rodriguez at NASA's Jet Propulsion Laboratory describes it as physically impossible under our current understanding of particle physics. How could a spacecraft designed to take pictures of Pluto become our best hope for solving the dark matter mystery? And what does this mean for our understanding of the universe? To understand why this mission is so revolutionary, we need to understand the dark matter problem and why it's been so difficult to solve. Dark matter is one of the greatest mysteries in modern physics. We know it exists because we can see its gravitational effects throughout the universe. Galaxies spin faster than they should based on their visible matter. Light bends around invisible mass through gravitational lensing. The cosmic web of galaxy clusters forms structures that require far more matter than we can see. All the evidence points to the same conclusion: about 27% of our universe is made of an invisible, mysterious substance we call dark matter. For comparison, all the normal matter that makes up stars, planets, and everything we can see accounts for just 5% of the universe. The rest is dark energy, another cosmic mystery. For decades, scientists have been trying to detect dark matter directly. The leading theory suggests it's made of weakly interacting massive particles, or WIMPs, subatomic particles that rarely interact with normal matter. To detect these elusive particles, researchers have built incredibly sensitive detectors, often placed deep underground to shield them from cosmic rays and other interference. The largest of these is the xenon detector at Gran Sasso Laboratory in Italy, containing 8 tons of liquid xenon cooled to -100 degrees Celsius. When a dark matter particle collides with a xenon atom, it should produce a tiny flash of light. Despite years of operation, these detectors have found no conclusive evidence of dark matter particles. New Horizons was never designed to hunt for dark matter. Launched in 2006, its primary mission was to study Pluto and the Kuiper belt. The spacecraft carries 7 scientific instruments, including cameras, spectrometers, and particle detectors. After its successful flyby of Pluto in 2015 and the Kuiper belt object Arrokoth in 2019, New Horizons continued its journey outward. This is where things get strange. In 2024, a team of theoretical physicists led by Dr. James Chen at MIT published a paper suggesting that dark matter might behave differently at the edge of our solar system. Their theory proposed that the boundary between our Sun's influence and interstellar space, called the heliopause, might create unique conditions where dark matter particles become briefly detectable. The paper caught the attention of NASA's New Horizons team, who realized their spacecraft was heading toward this exact region. Although not designed for dark matter detection, several of New Horizons' instruments could potentially be repurposed for this task with software updates. In early 2025, NASA quietly approved the Dark Frontier initiative, sending new software to New Horizons that reprogrammed its instruments for dark matter detection. The mission was kept classified until the first results came in, to avoid the embarrassment of a high-profile failure. But what New Horizons actually detected beginning in January 2026 was something far more extraordinary than anyone had anticipated, something that could revolutionize our understanding of the universe. What I'm about to reveal next is the detailed analysis of these groundbreaking findings and what the world's top physicists think they might mean for our understanding of dark matter. If you're fascinated by discoveries that could rewrite physics textbooks, this is exactly why I make these videos. Hit subscribe and enable notifications so you never miss these cosmic revelations as they happen. Trust me, by the end of this video, you'll understand why 2026 might be remembered as the year we finally solved the dark matter mystery. The story of this discovery begins on January 17, 2026, when New Horizons reprogrammed PEPSI instrument, Pluto Energetic Particle Spectrometer Science Investigation, detected an unusual pattern of particle interactions. Dr. Elena Rodriguez, lead scientist on the Dark Frontier Initiative, initially thought there was an instrument error. The readings showed particle events that didn't match any known cosmic ray profile. After 3 days of verification, the team confirmed the instruments were working correctly. The data was real. They immediately requested additional observation time from NASA's Deep Space Network to increase data transmission rates and gather more information. By February 2026, the anomalous readings had not only persisted but had formed a clear pattern. The team named it Signal Omega and began a comprehensive analysis. What they found defied explanation. The signal showed periodic fluctuations that correlated with New Horizons' position relative to the galactic plane, as if the spacecraft was passing through streams or filaments of dark matter. Dr. James Chen, whose theoretical work had inspired the mission, joined the investigation team in March. He noted something even more puzzling: the signal appears to be modulated by the solar system's movement through the galaxy. It's as if we're detecting a wake of dark matter that forms behind our solar system as it moves through the galactic halo. This was unprecedented. Previous theories suggested dark matter should be evenly distributed, not forming structures that respond to the movement of normal matter. If confirmed, this would require a complete rethinking of dark matter physics. Just as the team was grappling with Signal Omega, New Horizons detected a second anomaly on April 3, 2026. This one was detected by the spacecraft's dust counter, which began registering impacts from particles that shouldn't exist in that region of space. The team named this phenomenon dark dust. Dr. Sarah Jameson at the European Space Agency, who specializes in cosmic dust analysis, made a breakthrough discovery in May. These particles have properties that don't match any known form of matter. They're too massive to be normal interstellar dust, yet they interact with our detector, something that pure dark matter shouldn't do. It's as if we're detecting a hybrid form of matter that exists at the boundary between normal and dark matter. The scientific community was still reeling from these discoveries when, on June 12, 2026, New Horizons detected a third anomaly, the most baffling of all. The spacecraft's magnetometer registered fluctuations in the magnetic field that appeared to be synchronized with the other two phenomena. The team named it the dark resonance. Dr. Rodriguez explains, conventional dark matter theories predict no interaction with electromagnetic fields. But the dark resonance shows clear patterns of magnetic disturbance that correlate perfectly with Signal Omega and dark dust detections. It's as if the three phenomena are different manifestations of the same underlying reality. By July 2026, these three anomalies had become the most discussed scientific discoveries in decades. Research teams around the world were analyzing the data, proposing theories, and designing new experiments to try to understand what New Horizons had found. What made the mystery even more compelling was that all three anomalies appeared to be interconnected in ways that defied coincidence. Signal Omega's peaks coincided precisely with dark dust detections, which in turn aligned with the magnetic fluctuations of the dark resonance. As Dr. Chen put it, it's like finding three different pieces of a puzzle that fit together perfectly to reveal a picture we never expected. The statistical probability of this occurring by chance is essentially zero. We're seeing a new aspect of dark matter that no theory predicted. After months of analysis, scientists have developed three main theories to explain these bizarre findings, each with profound implications for our understanding of the cosmos. The first and currently most supported theory proposes that dark matter isn't a single type of particle but exists in multiple states or phases, similar to how normal matter can exist as solid, liquid, or gas. Dr. Rodriguez explains, "We now believe what New Horizons is detecting is a phase transition in dark matter that occurs at the boundary between our solar system and interstellar space." This theory suggests that the heliopause, the boundary where our sun's influence ends, creates conditions where dark matter briefly transitions into a more detectable state. It's like how water vapor becomes visible as fog when it condenses. The dark matter isn't changing its fundamental nature, but it's becoming momentarily observable. What makes this theory so revolutionary, adds Dr. Chen, is that it explains why decades of Earth-based experiments have failed to detect dark matter. We've been looking for it in the wrong phase state. It's like trying to detect water by looking for ice in a desert. The second theory proposes something even more radical, that dark matter and normal matter interact through a fifth fundamental force that only becomes apparent under the specific conditions found at the heliopause. This would be in addition to the four known fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces. Dr. Michael Patel at Caltech explains, the dark resonance suggests a force carrier particle, similar to how photons carry the electromagnetic force, that mediates interactions between dark and normal matter. We're calling it the darkon, and it would only be detectable in regions where the solar wind and interstellar medium create unique quantum conditions. This theory is particularly exciting because it might explain not just dark matter but other cosmic mysteries as well, such as the accelerating expansion of the universe attributed to dark energy. If confirmed, it would be the most significant breakthrough in fundamental physics since the Standard Model was developed in the 1970s. The third theory proposes that what New Horizons is detecting isn't dark matter itself, but the effects of our solar system moving through the dark matter halo of our galaxy. Dr. Rodriguez compares it to a boat moving through water. Just as a boat creates a wake as it moves through water, our solar system might be creating disturbances in the dark matter medium as we orbit the galactic center. This theory suggests that the heliopause acts as a boundary layer, where these disturbances become detectable. It would explain why the signals correlate with our solar system's movement through the galaxy and why they form patterns that follow our galactic orbit. What makes these discoveries so significant is that they don't just offer a way to detect dark matter, they potentially transform our understanding of what dark matter actually is. If confirmed, they would require rewriting physics textbooks and could lead to new technologies that harness dark matter interactions. As Dr. Jameson puts it, we're not just detecting dark matter, we're discovering that it's far more complex and interesting than we ever imagined. It's like the difference between knowing that atoms exist and understanding the full complexity of chemistry. Just when you thought you understood what New Horizons had discovered, the story takes another dramatic turn. In August 2026, astronomers using the James Webb Space Telescope made a discovery that added another layer to this cosmic mystery. While studying distant galaxies, they detected patterns of dark matter distribution that mirrored on a galactic scale what New Horizons was seeing at the heliopause. But here's the twist, these patterns appeared to be aligned along filaments of the cosmic web, the large-scale structure that connects galaxy clusters across billions of light-years. Dr. Hiroshi Tanaka at the National Astronomical Observatory of Japan explains the implications. Finding similar patterns across such vastly different scales suggests we're dealing with a fundamental property of dark matter, something that manifests both at the boundary of our solar system and in the largest structures in the universe. This discovery has led to a fourth, even more radical theory, that dark matter might be a manifestation of higher dimensional physics. Dr. Chen explains, some versions of string theory predict that our universe exists on a three-dimensional brane within a higher dimensional space. Dark matter might be ordinary matter that exists partially in these extra dimensions, becoming detectable only at certain boundaries or transition points. This theory, while highly speculative, would explain why dark matter interacts with gravity, which can propagate through all dimensions, but not with other forces that are confined to our three-dimensional space. It would also explain why the patterns detected by New Horizons mirror those seen in the cosmic web. Both might be projections of higher dimensional structures onto our 3D universe. Adding to the complexity, the New Horizons team announced in September 2026 that they had detected unusual correlations between dark matter signals and quantum fluctuations in the spacecraft's electronics. These variations show patterns that suggest dark matter might interact with normal matter through quantum entanglement, a phenomenon Einstein famously called spooky action at a distance. Dr. Elena Rodriguez notes, we're seeing quantum coherence effects that shouldn't be possible across the distances involved. It's as if dark matter particles remain entangled over vast regions of space, creating a kind of quantum network that pervades the galaxy. Perhaps most intriguingly, some of these patterns appear to correlate with unexplained quantum anomalies detected in laboratories on Earth between 2023 to 2025, suggesting a possible connection between phenomena observed at quantum scales and the behavior of dark matter throughout the universe. The question now isn't just what dark matter is, but how it might be connected to other fundamental aspects of reality, from quantum mechanics to the large-scale structure of the cosmos. And as New Horizons continues its journey into interstellar space, scientists are eagerly awaiting new data that might help resolve these profound questions. As Dr. Rodriguez puts it, we might be glimpsing not just a new particle or force, but a deeper level of reality that connects everything in ways we're only beginning to understand. It's not just a new chapter in physics, it's potentially a whole new book. I genuinely want to know what you think about these incredible discoveries. Which of these theories makes the most sense to you? Do you think dark matter exists in multiple phases, interacts through a fifth fundamental force, creates wakes as our solar system moves through it, or connects to higher dimensions? Or perhaps you have your own theory about what New Horizons is detecting at the edge of our solar system? Share your thoughts in the comments below. I read them all and I'm fascinated to see what this community thinks about one of the biggest scientific breakthroughs of 2026. The implications of these discoveries extend far beyond astronomy and physics. Understanding dark matter could revolutionize multiple fields of science and technology. In energy research, the discovery of dark matter interactions could lead to entirely new power sources. Dr. Chen explains, if we can reliably detect and eventually manipulate dark matter, we might be able to tap into an energy reservoir 5 times larger than all the normal matter in the universe. It would be like discovering fire all over again, but on a cosmic scale. For space exploration, understanding the dark matter environment could transform how we design spacecraft and plan missions. If dark matter interacts with normal matter in ways we're just beginning to understand, future spacecraft might need shielding not just from radiation but from dark matter effects, notes Dr. Rodriguez.